In the last couple of videos, we were looking at different types of sequences, and we focused on arithmetic sequences, which were sequences with a common difference. Now we're going to look at what's called geometric sequences. And essentially for geometric sequences, we'll say that the terms differ by a common ratio. And essentially the idea is, for the arithmetic sequences, we had something like 1, 3, 5, 7, and so on. They had a common difference, and you added. They were arithmetic sequences, you added to get from one term to the next. When we talk about geometric sequences, instead of using addition, we use multiplication and ratios. So we might have something like 1, 1/2, 1/4, 1/8, and so on. And in this case, how do you turn 1 into 1/2? You multiply by 1/2. How do you turn 1/2 into 1/4? You multiply by 1/2. How do you turn 1/4 into 1/8? You multiply by 1/2. So you're multiplying by the same ratio each time, which means this is geometric. Keeping in mind, there's lots of ways you can do this. You could have the sequence 2, 6, 18, 54, and so on. In this case, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So you're multiplying by 3, so your ratio is 3, and it's geometric. When we say ratio, we don't just mean a fraction less than 1. It can be anything. As long as you're multiplying by the same amount each time, it's geometric. One more. We can have something like 2, -4, +8, -16, and so on. And in this case, well, to turn 2 into -4, I multiply by -2. And then it's -4 times -2 to get +8. And then it's +8 times -2 to get -16. Which means if our ratio is negative, we can actually alternate the signs of our sequence from positive to negative. So there's lots of different things we can do. But to work with them, much like with arithmetic sequences, we need formulas. First off, we have the implicit formula. But it's pretty obvious from the ones we just saw. To get a sub n, you just take the previous term, a sub n minus 1, and you multiply it by the ratio, whatever it is, call it r. So the implicit formula, the recursive formula, is pretty straightforward and simple. But now, we need to find a way to write the explicit formula. We can do the exact same thing we did with arithmetic sequences to generate it. We'll start with one we know. Suppose for the sake of argument, we'll say a sub 1 equals 2, and the ratio is, we'll go with 3. Well then if we list the terms out, a sub 1 is 2, a sub 2 is 2 times 3. Again, much like with the arithmetic ones, I know that's 6, but we're writing it this way to get an idea of what's going on. A sub 3 is 2 times 3 times 3, which is 2 times 3 squared. A sub 4 is 2 times 3 cubed. We can see the pattern. 3 to the 1, 3 squared, 3 cubed. A to the 5th would be 2 times 3 to the 4th. And if we kept on going in general, a to the n would be 2 times 3 raised to what power? Well, a2 had 3 raised to the first power, a3 had 3 raised to the second power, a4 had 3 raised to the third power, and clearly, whatever this n is, the power you raise 3 to is 1 less than it. So this will be 2 times 3 to the n minus 1, since it's a sub n. That's the explicit formula for that particular sequence, but now we can generalize and do it for all sequences. So suppose we just let a sub 1 equal a sub 1, and let r equal r. I know that's redundant, we don't really need to write it, but whatever. So let's see. First I have a sub 1, then I have a sub 2. A sub 2 will be the ratio r times a sub 1. A sub 3 will be a sub 1 times the ratio squared. We saw that right here. Take the ratio and square it. A sub 4 will be a sub 1 times the ratio cubed. And if we generalize, a sub n will be a sub 1 times the ratio to the n minus 1, just like we got here. And now we have a nice explicit formula to find a sub n for any geometric sequence. Just take the first term and multiply it times the ratio raised to the n minus first power. So, as an example, sorry, I had to check. There was somebody knocking at my door, but they're gone now. So, let's see. Suppose we have the sequence a sub 1 equals 2, and the ratio equals, we'll say 1/2. Find a sub 6. Well, let's see. We just said a sub n equals a sub 1 times r to the n minus 1. So a sub 6 equals 2 times the ratio 1/2 to the 6 minus 1, which is 2 times 1/2 to the 5th, which is 2 times 1/2 to the 5th is 1/32, which means this is 2 over 32, which is 1 over 16. Which is, I think you can write 1 over 16, or it's 0.0625 if you want to write the decimal. These ones, even more than the arithmetic ones, because a lot of our ratios will be fractions and we'll be raising them to powers, the calculations get a little bit messy, but as long as you have your calculator, you'll be fine and good to go. Essentially though, that's pretty much it. We have this formula right here. Much like with the arithmetic sequences, there are some algebraic questions you can ask, but none I think that we really need to take time to do on the video. Most of them you should be able to figure out on your own, using the same principles that we use for arithmetic sequences. But essentially, that gives me arithmetic sequences, arithmetic series, geometric sequences, and then the logical question is, what about geometric series? What if I want to add up the terms of a geometric sequence? That's going to require a little bit more work, so I'm actually going to stop this video on the sequences, and then I'll do another video on just geometric series.